notations. Equations that are functions, you can write them as function notations. For example, this regular equation of y equals 3x minus 8, we can write that in function notation form by just removing the y and replacing it with f of x. F of x means the same thing as y, and it is read as f is a function of x, or the most common way to say it is just simply f of x. Think of it as a function machine. So again, always remember that f of x is the same thing as y. So notice with this regular equation you had y, all we did was remove that y and replaced it with f of x, and it then became function notation. When you see function notation, it's a clue that you're going to be plugging in some number into the function. When you have a regular equation, such as in the first case, normally you're just graphing that equation or so forth, or solving it. But when you see the f of x attached there instead of the y, then you're probably going to be evaluating some function, meaning plugging some number in. So think of it as a function machine where x is the value you're going to put inside the machine. X is your input, and what you get out is going to be your y value, or remember, y is the same thing as f of x, so it is what you get out, your output. So here we have three functions, and in algebra many times if you see more than one functions, you'll see them written in sort of like in alphabetical order. For example, notice the first function, we call that f of x. The next function, we call that g of x, and the next function, we call that h of x, just so that you can decipher between the different functions. So in the first example, we're asked to find f of 0. So we need to go to the f function. It has nothing to do with the g or the h function. So we're going to go to the f function, and into this function, we're going to plug in an input value of 0. So that means we're going to remove the x. It goes in x place always. Remove the x and replace it with 0. When we do that, it's going to look like so. And we can clearly see here that what we're going to get for an output is the value of -5. So f of 0 equals -5. In the next example, we want to evaluate g of -1. This has to do with just the g function, g of x function. Okay, so don't worry about the f of x or the h of x. It doesn't concern those functions. We have to plug this into the g of x function. So in x's place, we're going to remove the x and replace it with a -1. So when we do that, it's going to look like so. -1 squared equals 1. 1 plus 1 equals 2. So therefore, g of -1 equals 2. Lastly, we want to find h of -2. So we're going to go over to the h of x function, and in the x place, we're going to remove the x and replace it with -2. When we do that, it's going to look like so. So when we solve the bottom, -2 combined with a +4 is going to give me a 2. So that will leave me with an output of 1/2. So h of -2 equals 1/2. Now recall we talked about in the previous lecture the various ways in which a function or relation rather can be represented. We can represent a relation in the form, recall, set of ordered pairs, table of values, a graph, mapping, and so forth. But here we have a set of ordered pairs, and we're asked to find f of 5. So with an input or an x value of 5, we only have 3 ordered pairs, and of those ordered pairs, the only one that has a 5 in x's place would be the second ordered pair. And so if you have a 5 in x's place, what do you have as an output in y's place? Well, you can see that your output in y's place would be -6, so therefore f of 5 equals -6. Here we have a mapping and we're asked to evaluate f of 4. So with an input or an x value of 4, we need to see what was the output or the domain. So out of all the x values, the last one is the one that has an x value of 4. So we need to see what is the y value or the output, and the output is -1. So f of 4 equals -1. Here we have a table of value representation, and we want to find f of -1. So putting in an input value of -1, we want to know what is our output, our y value. And we can see here for the x values, we go down to where we have -1 as our input to see what is our output. And as we can see, our output would be 1. So f of -1 equals 1. For the function value f of 3 equals -4, write a corresponding ordered pair. Here, all they want us to do is to simply do the opposite. This time you were given the function, the input, and the output, and you're asked to write it as an ordered pair. So as an ordered pair, the x value would be your input. So in the x's place of the ordered pair, I'm going to have a 3. Your output is your y value. So in y's place, I'm going to have a -4. So my ordered pair then would be 3, -4. Let's look at the second example. G of 2 equals -1/2. So what is your ordered pair? If you said 2, -1/2, then that is correct. The next objective is to use a graph to find the value of x for each value of f of x. In this example, we're asked to use the graph to find the indicated value of the function. So here we're given f of 2. So recall whatever you see in the parentheses is your input. In other words, it's your x value. So I have an x value of a 2, and what they're asking us is to find out what would your y value be of that ordered pair. So let's go on the graph, and I'm going to start first by plotting my x value. If it's 2, I need to go over 2. So 1, 2. Now I am not on the graph. I want to position myself on the graph. So to get there, I need to go up 1, 2, 3, 4. That was my y value. So to get there, that was y, which was 4. So my output is always your y value. And notice here, the output of my ordered pair is a 4. So therefore, f of 2 equals 4. Next, I want to find f of -3. My x value now is -3. So on the x-axis, I'm going to move over 3. 1, 2, 3. To get on the graph, I need to move down. So my y value is going to be a negative. So let's go down. 1, 2, 3, 4, 5, 6. Which means that My y value here of my ordered pair is -6, so therefore f of -3 equals -6. Let's do two more examples. Use the graph to find the indicated value of the function. First, we want to find f of 0. So our input value is 0. So we're going to go over to our graph, and on the x-axis, we're going to position ourselves at 0. Well, we are already on the line. We're on our graph. So that means my y value will also be 0, because that is where I am. And so f of 0 equals 0. Next, I want to find f of 4 with an input or x value of 4. So let's go over to our graph, and we're going to move over 4. 1, 2, 3, 4. I am not on the graph. To get on the graph, I need to move down, so my y value is going to be a negative. So to get there, I need to go 1, 2, 3, 4. That point or position is 4, -4, which means that my output, my y value, is a -4. So therefore, f of 4 equals -4. That's it for this video. Thank you for watching.